Welcome to my RStudio class. Today I want to demonstrate how you can perform chi-square and t-square, t-test in R. We will import data, create a script, clean the data, and then run all of this. So I already have R and RStudio installed on my device. If you do not know how to install R and RStudio, because you must install R and as well RStudio, leave a comment for me in the comment section. I will make a short video to guide you how you can install R. Meanwhile, if this is the first time you have come across my videos on this space, please hit the subscribe button, hit the bell notification button, as well as you will also need to hit the like and the share. Or if you are seeing this video on TikTok, I will appreciate your follow. One of the things that I do very well is that I know how to follow those who follow me back. Thank you very much. God bless you. So the first thing we need to do is to create a script. That means the environment where we will carry out our coding or programming activity. So what we need to do is to first click on the file on the top left corner over here, and then select a new file. Then from there you click on R script. You can equally do it by clicking Ctrl+Shift+N. So this is our script. Before we do anything, I always encourage my listeners or students or people I mentor to save the script. Now, before we even save the script, you need to determine where you want your script saved, so that when you need to record it, you won't need to stress too much. So let's assume we're going to create a file in the document environment of your computer, and then you right click and then come up to create a folder as you normally would do. Here's the folder. Let's say we name it R_tutorial. Right? Tutorial. Okay, so we have our folder saved. So we'll go back to our environment and first of all click save. When you click on save, wait for it to go back to your document environment and then look for that R tutorial that was just created. This is it, and then you click open. At this point you need to name your file. Let's say TTest chi. That means TTest and chi-square, and then you hit on save. Now you will see that the script has been created, and that is the name as you have it. Then the next thing you need to do is that you will make comments to tell your readers or to remind yourself what your script is doing line by line. So at this point I will write that we will set working directory. Right, this is the space where R will save all of your work. Now whenever you are making a comment, you start with a hash key, just like you have seen, and you see that it turns green. That means that when the program starts to run, it will not perform that portion of your scripts. So then set working directory is written by SETWD. Then you open bracket, and then go back to your our environment, right click we just want to get the name of our folder. So when you right click, you select file, you select properties, then you come down to this location environment and copy the name of your file location, which must be inserted in double inverted commas or simply double quotation mark. You as well go back to copy your folder name and then you paste RStudioTutorial in that space. Please note that the slashes must be forward slashes, not the backward slashes. So this is the file location where all my activities will be saved. Now when you hit on Ctrl Enter, you can see over here down on your screen, bottom part of your screen, that the script has been executed, and that's why it's showing blue. If whenever you see a red something in red, it means that your script has an issue. Okay, next thing is to after you have set your working directory, the next thing you need to do is to call the relevant library. And for this particular analysis we want to perform, the library that we need is dplyr. So library, you type library, you see, and then you now type dplyr. This is the library that will perform TTest as well as chi-square for us. So either you click on run or you click on Ctrl Enter to run your scripts. Then the next thing we need to do is to call, I like to use the word call or import. Okay, call or import your data. Alright, so for me to call or import my data, I will like to use a certain data that is called medical. I've used it previously, so I will go over now to, let's say here. Okay, so I will copy my data that I intend to use. So to call your data, you must first of all assign vector. And how do you assign vector? Let's say you are going to call your data by a name. So let's say we're calling it tutorial underscore data. You don't use spaces in R when you are naming your vectors or naming columns. And as much as possible, it is expedient for you to use lower cases. At the same time, you should note that you can mix numbers and letters of the alphabet, but you cannot start a variable name with a number, okay, so that the script will not get confused. So you will now assign the variable name to the vector. To do that, you press on Shift, and then what you simply need to bring up is the less than key, and then you include a dash, leave a space, then you say read.csv. Our data is in CSV format. This is the reason why it is read.csv. So paste. Now why I needed to paste is that I don't want to waste our time. We already have something like this over here, but what we have now is that I am calling that data from a particular location, and the data is called let me say I should use the data that is called medical. check now to see if that data exists in that location. It does not exist in that location. So if it does not exist in that location, I will need to go and copy it. I will need to go and copy it from the location it is and bring it over. So I'm changing where this data can be found. Okay, where this data can be found, and I now want to take it, literally go and copy it from the location where it is stored and take it to our current folder. So the data says the name of the data is medical, so I'll copy medical from here. This is not part of what I'm showing you, and then go to documents and then get to our RStudio folder and save the data here. Now that I've saved the data here, when I go back to R and run this particular line of scripts, the data has been imported to this R environment. As you can see, there's a blue indication of our talking about this now. There's a blue, it's colored in blue, meaning that it has run successfully without any issue. I would like to view the data. So to view data, view the data. To view the data, you type view. View in R starts with the capital letter. The first letter is the capital letter. So view tutorial data, and you can see that it has popped up. When I save view and I run, highlight it if you like, or simply just put your cursor at the end of it and click on run, the data will open for you to see. So this is how a data gets to be imported to our environment and viewed. Get to be imported in our environment and viewed. Okay, the next thing for me to do now is for us to create a new data set, right? So create a data frame from this tutorial data, tutorial underscore data. Okay, using a particular, we are going to use some subheads. I'm using this subhead as well as this other subhead. Now before I can do that successfully, I will need to view the column names so that it can be easy for me to copy. So first, I think I should do that here. So view column names. So to view column names, I will simply just give it a name. Let's say just say column names, right? This first one here, and then tell it to do that for the data called tutorial data. Run these scripts by clicking on run. All of these are the column names for our data set. So like I mentioned earlier, I am interested in this particular data column, this column. So I will paste that here using this one and this other column name. These are the two column names that are of interest to me. So I'll create a data frame that has something to do with it. So let's say now our data frame, we need to give it a name. Let's say our data frame is just data, or let's say data 1. say data 1, you assign variable name using that particular sign that I mentioned before. Then you tell it that you are creating a data frame, data.frame, and the data source, which is tutorial data, and then you use square brackets, introduce a comma, and create columns by using the function C, open bracket. Then the data are these two, so let me just copy from here, copy, paste inside of this space, separate with the comma, and then the second, copy it and paste inside this space. Okay, let us see. Alright, so that first comma is not needed. Then let me run that line of code and see. I ran the line of code and it is working well. So let us now view the data frame that we have just created. Remember to view the data frame, that is data underscore 1. And to view that, you just type VLIEW bracket and you say data underscore 1. You run that line of code, the data frame has been created, as you can see. Okay, so then before we go ahead to do anything, it is always necessary to clean the data. How do you do to clean data? So let's write that comment. Say clean your data frame. So to clean our data frame, we will now rename it and say data underscore 2 now, or simply say data underscore 1 underscore cleaned, or clean, assign variable name, and you now say na.omit data underscore 1. Now note that it's data frame, the data frame called data underscore 1, that is what we are performing cleaning on. So when you click on your line of your run key, the data is now cleaned. If you want to check, do we need to check? If you want to check, you will need to say that you want to sum the number of missing values that we have. But let me not do that, so that I will save your time. If you want to know how to check for missing values in your data, please let me know in the comment section, and I will make a video quickly to demonstrate that to you. In the meantime, if you have just joined this video and you know that you are not yet subscribed to my channel, or that you have not started following me on TikTok or Facebook or Instagram, I kindly want to implore you to please kindly do so to help this channel. So now we have cleaned this data. We now want to perform t-test. We now want to perform t-test. So perform t-test on the cleaned data. Okay, so that is the next thing that we need to do. So we now will go ahead to perform t-test. And the type of t-test that will be performed is independent samples t-test. I have typed the script just so that we will save time, since my typing speed is quite very slow. We're having this line of code here. Check it out. It is called t-test results. We assign that to t.test. Our data is data1 cleaned, and the column name which we have here in the data frame that we had created earlier, and separated with the comma, data1 and the column second column that we have. Next is we are including more or less that the removal of NA in case there is any missing values within the data frame, that the computer should remove that. So that's why we're having n.rm equal to true. After that line of code, we will now need to create a table that will depict or display to us all of the the statistics that will be revealed or be found out by this analysis. And what are the things we are looking to see? We have, first of all, group 1, which is the first column, group 2, which is the second column. If you are familiar with t-test, we need to see the means, because we are comparing means. So we need to see the means of the variables being compared. So mean 1 is for this first column here. So we say mean 1, that is the data data 1 cleaned, and that column. Or again, we're still including a portion, an argument for removing missing values. Then mean 2, we do the same thing for mean 2, data 1 underscore clean, and then the second column also remove missing value. And apart from the names of the groups and their means, we also will need to see the p-value of the p-values of the analysis. So with that, we say t-test result $ p-value. $ is used to combine a particular, maybe from a particular data set and a particular row that is involved in that, a particular column that is involved in that analysis. Then we need also to see the t-statistics. The t-statistic is t-test $ statistic. All of these are activities that are performed in the background, which are not necessarily visible to the eye. Then we also need to see the data, we call it degree of freedom, DF. So, and that again is t-test result $ parameter. Then we close the bracket here. So this portion of it, the function of this is going to help us create a table, and that's all. Next, we will need to print the table, which you already know how to print the table, and we also need to view the table. Then I've also included an interpretation criteria here, where it says it should reject the null hypothesis and state that there is a significant difference between isomers if t-test p-value is less than 0.05. Else, you should accept the hypothesis and tell us that there is actually no significant difference in the two variables being compared. So this is t-test. What do we need to do? All you need to do now is to highlight the entire script of t-test. Either you click Ctrl Enter or you select Run here, and the analysis will be performed. And then, of course, the table is created. As you can see, as beautiful as simple as it is, it's a very beautiful thing to use. So, guys, if you are getting some value from this video, I will encourage you to please hit the subscribe button, give me a follow, give me a thumbs up, and as well as share this video with your friends who might also benefit from it. Thank you very much. Now, after taking care of this, now the next thing we need to do is to perform chi-square. So let's say perform chi-square. So we're going to now perform chi-square. So come with me as we proceed. So the first thing we need to do is to create a contingency table. And to create a contingency table in R, as usual, we need to create a vector name, and this is the way you assign a vector name. Then you use the function table, and then remember that the data we are dealing with is data 1 clean. That's the data underscore 1 underscore clean, and then this again is the name of the column in that data. If you are wondering how we got it, all you need to do is to press shift on your computer if you are using a Windows device like mine, and then you press the $sign, then that column comes up. And I'll just repeat this for you at this point because I noticed that in the other Windows section I didn't do that. So shift 4 where the $sign is, and then pick the column that you're interested in. After then, when you run this, you have your contingency result or table. Then the next thing you now need to do after that, you need to perform chi-square test with Monte Carlo simulation, and that is you write the code chi-square result, assigning this vector to chi-square.test contingency table, open bracket contingency table, comma, simulate.p.value equal to true. Next, you need to calculate your degree of freedom, because these are all the statistics that you will need to display on your table. So degree of freedom, which is this DF here, is number of rows of contingency table minus 1 times number of columns of the contingency table minus 1. So having done that, we'll now go ahead and assemble our table. Create a data frame for the chi-square results, and that is to create a data frame. You know already that you create a vector name and you start with data.frame to create a data frame. Alright, so that's where we have that. Open a bracket, group name is the first column, group 2 name is the second column. We don't need mean in this case, that's why mean is not involved. Chi-square value is equal to chi-square result statistic. Then degree of freedom is equal to the degree of freedom we created over here. So, and then p value is the chi-square result $p.value. Then of course you print your chi-square result just like we did in the case of TTest. And then down over here, I have decided to include for you the interpretation of the results obtained. So before you rush to run your code, you need to go over it all over again to be sure that you have not made any mistake. And when you are sure that you have done all that needs to be done, highlight the whole script, click on run. Having done that, you can see that the table has been created both here on the console as well as in the form of data frame. So this is the chi-squared, and we are having group 1, group 2. Chi-square value is 249.7425, and degree of freedom is 25, and the p-value is 0.0004997501, and so on and so forth. Now, if you read over down this side, you discover that it says reject the null hypothesis, and so it means that there is a significant association between the two columns. So guys, this is how you run chi-square, and if you got value from this video, I will implore you to please hit the like button, hit the subscribe button, share this video with your classmates, those of you who are university students, and if you're a professional just taking data analytics course, very good, help me to share it among your friends. And if you know that you are interested in having access to these scripts, you can leave me a comment in the comment section, and I will send the link to this script over to you. Thank you very much. Please support my channel, and I will see you on the next one.